Welcome to the ACORD demo and ACORD and its use cases demonstration. So as you all know, the CORD stands for Central Office Re-architected as a Data Center, which aims to transform the telco central offices much like data center by bringing the data center principles of economies of scale and cloud-side agility. So in this transformation process, CORD imagines a telco central office as a collection of three important things. The first one is it's a collection of commodity compute and storage nodes interconnected with inexpensive leaf-spine, white box fabric and disaggregated I/O devices. The second part is virtualizing some of the physical appliances like virtual CPE devices or the OLT and the BNG applications that were today running in a physical custom hardware, which are getting virtualized and running in a much more microservices model on the cloud infrastructure. The last one, but very important one, is it uses a service orchestration layer composed of all open source software building blocks such as XOS, OpenStack, Docker and ONOS SDN controller. You can find more information about the CORD on the web on the open source cordproject.org. And this demonstration is particularly about the analytics part of the CORD service orchestration. So ACORD, that stands for the analytics CORD, which is a unified monitoring framework inside the CORD service orchestration layer that provides dynamic observability for the various network elements that are present inside the CORD infrastructure. So it could be the compute nodes, storage nodes, or the I/O devices, disaggregated I/O devices, or spine leaf fabric. And not only that, ACORD enables you the monitoring of the service information that is running on this infrastructure. Some of the key highlights of this ACORD platform are it is access and domain agnostic, such that it is a monitoring platform for multiple vertical solutions that we have: residential CORD, mobile CORD and enterprise CORD. And also another key aspect of ACORD is it provides you adaptive instrumentation capabilities, where applications can program their level of monitoring data that they want from the underlying network. They can specify whether they want broad but minimal level of monitoring or narrowed down but deep level of monitoring. So this is the flexibility that ACORD provides using this adaptive instrumentation capability. So there are several applications that are built using the ACORD platform, and we are demonstrating some of them during this ONS 2016. And the first category are the dashboard applications that are built in the residential CORD, which leverages the ACORD's query capabilities to extract the various probe data that is collected from the residential CORD elements into the ACORD system and display in the dashboard. So there are two dashboards that are present today. One is the monitoring dashboard application, displays the health of the cloud resources associated with a particular residential service that is instantiated in the ORCOD. And the other application is the subscriber diagnostic portal that does the correlation of the events coming out of the ACORD and find out the health of cloud resources associated with a particular residential subscriber. This is the portal application that is useful when a customer care receives a complaint about subscribers' connectivity issues, so that they can open up this portal and finds out what is happening for that particular subscriber on all the cloud resources, either compute, storage or the network related. So these are one type of applications that leverages the ACORD's query capabilities, which are provided by the ACORD platform. The next set of application that I am going to show you is the leverages different capabilities of the ACORD. So this application is called Autonomic Anomaly Detection and Mitigation in Mobile Network. This application leverages the ACORD's publish subscribe interface and the dynamic adaptive instrumentation capabilities. So as you see here, we have the mobility network through which the subscriber traffic is going. So initially the AADM application will subscribe for, will enable the, will monitor all the subscriber traffic that is flowing through the underlying network, but only gets the minimal information, which is the control plane traffic events. So when the traffic is flowing through this network, the virtualized MME generates the traffic events into the A card that are in real time delivered to the AADM application, which will be analyzed for presence of any suspicious behavior. So once AADM application detects any suspicious behavior, they will use the adaptive instrumentation capabilities of ACORD to dynamically insert a probe to perform the deep level of inspection on a narrowed down of subscribers, so that this dynamically activated probe will inspect the user plane traffic coming from the subscribers and generate some deeper insights into the ACORD system that will be delivered to the subscribed application. So once AADM application has both control plane event data and the data plane event information, it can do the better correlation and exactly confirm the presence of the anomaly in the traffic and can take correct mitigation actions. So this is the application that we are going to demonstrate here, but we are going to demonstrate only the first part of it, where the AADM application detects the first stage of anomaly in the subscriber traffic. So as you see here, the 6 steps are AADM application subscribes for the control plane monitoring of all the subscribers, and when the subscriber traffic is flowing through the network, the control plane element MME generates the traffic events, which gets in real time notified to the AADM application that gets analyzed and displayed in the dashboard. Also in parallel, we are showing the dashboard application that we have built as part of the residential card can query the data that is collected by the A card and display in its own dashboard. And whenever we inject the anomaly here in this scenario, we are simulating the anomalous traffic into the network, which will be detected by the AADM application and result in a red line in the dashboard of the AADM application. So I will first show you the monitoring dashboard application, which is built into the card. So what we are showing here is the card dashboard that displays you various metrics that are collected by the ACORD platform. So here I am showing you the various services that are listed and the corresponding health of the cloud resources that are associated with these services. So currently what I am showing here you the compute level, infrastructure level monitoring information like compute, storage and the network level data, where you can find out more details about each of these monitoring data by going inside the samples that are collected by the ACORD platform. Similarly, not only infrastructure, ACORD enables you to collect the service level events. So as you see here, we have various service level information collected by the ACORD platform, where we have multiple IMSI subscriber terminals connected to the MME device, virtualized MME, from which each of which is collecting a different set of events from those subscribers. So if you go deep into that event, you will find out at what period of interval these events are getting collected by the ACORD platform. So this is the card dashboard that we have built to display in a static fashion all the collected data. Now I am going to show you the dashboard that anomaly detection application and mitigation application uses it. So here is the Grafana dashboard that gets the data from the ACORD using the publish subscribe interface and analyzes various characteristics of it. The most important metric that it observes is the number of subscribers session requests that it is getting over a period of 1 minute through the network. And the machine learning algorithms of this application will observe the traffic events for a certain period to get a baseline of what is the typical average subscriber session requests that are flowing through this underlying network. So as you see here, the topmost, the green line indicates the number of subscriber service requests, which is the average. As per this observation, it is always below 60. The subscriber service requests are whenever the subscriber terminal browses a URL from his mobile phone, that is when the MME element generates this subscriber service request. So at one point of time, we are injecting the anomaly into the network. What that anomaly simulates is it will, in a rapidly fashion, it will inject the subscriber session request, so that there is a spike in the number of subscriber service requests that are observed by the AADM application. So as you see here, there is a spike from 60 service session requests to almost like 100, which triggers an anomaly, which indicates some type of suspicion in the network. So the dashboard displays it in the red color, and also along that it also displays the subscribers that are causing the anomaly in the bottom part of this dashboard. So this is the part that we are demonstrating in this particular demo. At a high level, the architecture of ACORD is comprises of data collection services and the adaptive instrumentation services. So currently we support two types of data collection: the oscillometer based data collection and death flow based data collection, through which we collect the data from the CORD infrastructure layer, the service VNFs running on that infrastructure, and the dynamically activated probe. All this data is collected by the ACORD platform, which is stored in the time series database, and in real time they will be notified to the subscribed applications using the PubSub interface. So thank you for listening, and this is all about the ACORD. So you can find more information about this analytic card on the opencord.org website, which will provide you the white paper and the code base that so far we have built for this ACORD. And thank you for listening.